Hi, this is Moser with a quick hints and tips on your 4B problems associated with the Holt Physics book. This is the 4B worksheet and it's number 4. We have a Bulgarian named Minchev, and he's lifting, well apparently he's a power lifter, 157.5 kilograms, though he only weighs 54, so he's lifting about 3 times his own mass. We want to know what the force acting up on each of his feet is at the moment he was lifting the mass with an upward acceleration of 1.0 meters per second. We're going to assume that the downward force on each of his feet is the same. In other words, he's standing evenly. That helps. So let's start, as we do everything, with a Freebody diagram. Now remember that just to stand there by himself, Minchev's got an upward force on him equal to the force of gravity downward on him, which is equal to his mass times acceleration due to gravity. When he adds the weight, he adds a downward force on himself of the force of gravity on the weight, and he's holding it, which also adds to the normal force upward on him, so that as long as the floor isn't collapsing, these two are still the same. Now, that's if he's just holding the weight still. That's not if he's accelerating it. This does get a little bit tricky. We're going to have to consider this almost as two problems that we get to set equal to one another in the end. So first let's talk about the weight, and let's do a quick sum of forces because the weight's pretty easy to deal with. So we know that we're dealing with the y-axis only, and that the sum of forces of the weight on the y-axis is equal to the mass of the weight times the net acceleration that the weight is undergoing. Now, note that I've gone ahead and just used acceleration of the weight, and I'm using these subscripts, the W's, to refer to things on the weight. Now, what else is the sum of forces on the y-axis equal to? Well, just like every other case we've ever done, it's equal to all the forces up minus all the forces down. And the force that we have up on this weight is the force of Minchev. We'll note that as force of Minchev on the weight, which is FMW, minus the force of gravity on the weight. So that would be the mass of the weight times G. Okay, so we have the force of Minchev on the weight minus the mass of the weight times gravity. And we know that these two things are equal to one another. So we can take this and stick it right here. Wow, that's nice. And we know the mass of the weight, and we know the acceleration of the weight, and we know the mass of the weight, and we know gravity. Okay, cool. Now we're going to set that aside. So now let's talk about Minchev. So let's go ahead and do a sum of forces on the y-axis on Minchev. Well, the first force we've got, and I guess I should go back and say that the sum of forces on the y-axis on Minchev is equal to all the forces up on him minus all the forces down. And we know he has 2 feet, and we know he's standing on them evenly, so we know that there's a normal force on foot 1 and a normal force on foot 2. Okay, that's easy enough. Now comes the more difficult part. We know that there's a force of gravity on Minchev, which we know is equal to the mass of Minchev times gravity. But is that the only force acting on him? As he's accelerating that weight upward, that weight is exerting a force on him equal to the force that he's exerting on it. Oh. So we also have to add that as a downward force. We're going to call that the force of the weight on Minchev. And we happen to know that the force that Minchev exerts on the weight equals the force the weight exerts on Minchev. Okay, well, great. Now, how do we figure this out? Well, first of all, let's go ahead and clarify. Is Minchev himself accelerating? No, he's not. So, therefore, we know that this sum of forces on the y-axis, his mass times acceleration, is equal to 0. Well, that's going to make things considerably easier for us. So we can rearrange this to find that 2 times the normal force is equal to the mass of Minchev times gravity minus the force the weight's exerting on Minchev, which we know is equal. Well, let's go ahead and take this and rearrange it to solve for the force of Minchev on the weight, or the weight on Minchev. We know that the force of Minchev on the weight would be equal to the mass of the weight times the acceleration of the weight plus the mass of the weight times gravity. Okay, well guess what? That, folks, is something that can be plugged in to here, and I think you can probably take it from there. Good luck.